to start, I'm just going to give a brief overview of Fleek and the different products we're working on. And then Samuel is going to give a live coding workshop of actually using the Space Daemon to build an app, or for other people who are interested in building apps. And so to start, Fleek as a company, we started 2 years ago. Our main focus is building tools and products that help leverage Web3 technologies and make them accessible and easy to like extract the value and like the unique like aspects of these new technologies and protocols. And so to start, the protocols we're focused on like entirely are IPFS and Textile, and now Filecoin is being added to that mix as well. And so on the Fleek side, Fleek is a developer platform, and we started with our main product, which is an IPFS hosting product. And so basically with that, you can easily host a dApp or any front end. Doesn't have to be a dApp. It could be, you know, a normal site or Web 2 application. For static hosting, it makes the process super seamless. We handle all the behind the scenes things like auto updating IPFS hashes when you do a new deployment, making it like a seamless process, one click, link your GitHub, and the rest is automated. It also comes with ENS support. So if you are using an Ethereum name for your dApp or your site, we make that process super seamless, where we auto update your ENS name with the new hash every time you make a new deployment. So we have several thousand sites that are deployed through Fleek onto IPFS. And then with that product, one of the things we've done is essentially augment IPFS with some centralized infrastructure to make sure it's super performant. And so besides just like the IPFS pinning infrastructure, we're also putting those front ends on Cloudflare CDN. So the difference between hosting it on IPFS or hosting it on, you know, AWS or Netlify or wherever someone would normally host, the performance is the same, if not better. And you know, there's no downsides. And that was one of the goals we wanted to achieve, is how do we make, you know, using IPFS for different use cases just as good as, you know, the Web 2 experience is currently. And so then we also added a storage product and a pinning product. So essentially, instead of just adding these benefits to front ends, you know, any files or that you're using IPFS for, whether it's images for NFTs or audio files, you can get those same benefits that we provide to like our hosting and for front ends, which is essentially like built-in CDN compression, auto pinning, you know, trying to take away all those headaches and make it super easy to just upload files to IPFS, pin them, retrieve them, and make it super performant. So we built those two products, and then really from building the storage product as a developer tool, we sort of felt that you know, given the main benefits of the technology that we wanted to go after were the privacy, encryption, and P2P benefits of the technologies, especially with IPFS and Textile, you know, we felt that we were building a lot of these cool tools, but maybe it would be great if we could showcase some of the things that could be built with these new tools and with these new technologies. And so that's where we decided to build the Space Daemon and the Space app. So the Space app was an idea we had to essentially, you know, the technology and where it is today and the low-hanging fruit use cases where we thought we could extract, you know, those main benefits we wanted to go after, which were privacy, encryption, and peer-to-peer. We felt that like a work collaboration platform like G Suite and Google Drive and like the Google Docs and those type of apps you use with Google Drive, and just cloud storage in general was a really good use case that we felt that the technology and the protocols could handle today. And so we wanted to build Space to kind of showcase like what could be built on top of these new protocols. And so Space is essentially a file storage and sharing and collaboration platform built on IPFS and Textile, with like backup storage in addition to storing it on like IPFS and Textile nodes that we run, or other companies like Textile run, or it's open source so anyone can run. Could also be backed up to Filecoin in the future. But when we wanted to build Space, what we realized was there was a lot of like groundwork we needed to lay in order to just be able to do simple things like upload files, share files, and a lot of the work that Textile's been doing, to really like make it a seamless developer experience and package it all nicely to make the app building experience super easy. And so the Space Daemon was essentially the kind of back end framework we used to build our own Space app, but we open sourced it because we realized that it could be useful to anyone trying to create these P2P encrypted DWeb apps on top of these protocols like Textile and IPFS and Filecoin. And so that's where the Space Daemon kind of came into existence 2 months ago. We have 20 plus projects that are building apps on top of the Space Daemon already for tons of different use cases. And so it's super cool to see that. It is open source, so new modules are being built by us, by other people now contributing to it. So we highly encourage that and recommend people to share ideas or feedback, and let us know if there's anything cool you think we should add or that you're interested in adding. Anyone's welcome to submit pull requests. But that's sort of what Fleek is. So our main 3 products are the Fleek platform for the developer tools such as hosting and storage, and we plan to add other products to that suite as well, for just things you might want to do, or how you might use IPFS and Textile databases, serverless functions, authentication. These are the types of things we're thinking with. So we have like a full DWeb app and all the services you might need to build those in a platform. And then the Space Daemon is a separate open source project. There's a GitHub for it. That's the best place to find out information about that. And then we have Space, which is like a private encrypted P2P version of Dropbox or Google Drive. We're launching the V1, which is like the Google Drive equivalent, in about a week or 2. It'll go out to the first beta signups. And then we'll be building apps like a Space Docs, like a word editor, real-time collaborative word editor, and then kind of other work collaboration apps that, similar to what G Suite has. And so as we build additional functionality for the things we're building for Space, such as a browser version of the Space Daemon, which is coming next, and new things like Taurus as an authentication option, things like that. These will all be available to other people building on the Space Daemon and Surface. So it'll just get easier and cooler to use it to build apps in different ways in the future. And so the Space product will be open source as well. The sort of the cloud, the storage and collaboration platform. And so the idea is, well, we might build the first few apps like the Google Docs and Google Sheets equivalent. The idea is, since it's open source, other people could potentially build these apps and it be an open app ecosystem, and they could be surfaced and kind of all follow this common framework for these DWeb apps, where it's user-owned accounts, encrypted, all built on Textile threads and buckets, data's on IPFS, And one of the cool parts about it is, you know, the serving of the content for the apps are can be tweaked and optimized, but it the delivery of the content can be served peer to peer, not just from backup remote IPFS nodes that you know, we're running centrally or third party is running. And so that's where we are really excited about the technology. Is we feel that one of the coolest benefits of IPFS is as a new data transport layer for the web, where you could offload bandwidth to users without them really knowing, or their behavior having to change, or the app experience having to change. And you can create these sort of like app or site specific like BitTorrent networks, where users are not only consuming the content, and the app or site creator or operator is the one paying for all the bandwidth for all the requests to all the users. With this, you could, you know, offload a ton of it, where, you know, sure, there's backup requests being served that you're paying for when users are offline, or it's a new content that needs to get seeded, but then you could have users start to seed the rest of it. And it just seems like a very natural evolution of the cloud, where, you know, now the edge is the big thing, where, you know, it was CDNs, now it's the edge, and all with the goal of trying to get closer and closer to the user to reduce latency and make a better experience and reduce costs. The end goal, in our opinion, would be that you can't get any closer to the user than the user's own machine. And we feel that if you can put an IPFS node on user's machine, whether it's in a desktop app like it is with the Space Daemon, where it's part of the app when they download it, or it's natively in a browser like Brave or Opera, or maybe other main browsers in the future, these things will just get easier and easier, where then you wouldn't even have to put an IPFS node in your front end code when you're building a web app. You could just leverage the browser's built-in IPFS node and take advantage of all these cool benefits that are built into the Space Daemon and these protocols that are just improving and getting better and better. And so that's another part of the cool thing about the Daemon is, you know, right now it's mainly it's ideal for a desktop app experience. And the reason for that is because we could actually put an IPFS node and a textile node and the things we need in the user's machine itself, so they can, you know, query content and, you know, cache things and serve and request things directly from the user's machine, and have their own essentially local IPFS node and textile node to handle pretty much everything. And that's what really enables us to take advantage of the peer-to-peer. But as I mentioned, expanding it to a browser makes sense. The peer-to-peer aspects of what we're doing and offloading bandwidth to users wouldn't work so well in a browser context today. But as the technology improves, as it becomes, you know, more feasible to do these things in a browser, as browsers natively integrate these protocols, all these things would become easier. And that's where we really see things going. And that's kind of what we're building towards. So that's kind of an overview. If you have more questions, you're more than welcome to ask here, or, you know, find us on Slack, and we'd be happy to help. We're very like in contact with all the projects building on the Space Daemon or using Fleek in general, and we love working with all the projects in the ecosystem. Yeah, so that's a basic overview. I'll hand it over to Samuel now so he could get to the fun part.
So now that Harrison has us fired up to make apps on the Space Daemon, I'm going to show you how to get started with that. So my name is Samuel. I'm a front-end developer at Fleek. And since I am a front-end developer, I do a lot of Space Daemon integration in my day-to-day job. So in the next like 30 minutes, I'm going to show you pretty much like how to do my job. So I'm going to like give you a tour of the GitHub repos so that you know how to get the information that you need, where to get the daemon. I'm going to show you also how to use some basic functions, like how to upload files, see files, how it's organized in the daemon. So it's going to be an introduction. That's the website for our Space app that we are building right now. And as Harrison said, the Space Daemon is like the back end of our space app, which means that as we develop our app, in a way, we add more features to the Space Daemon. So like soon it's gonna go in alpha and then in beta, and we're gonna add more and more features like notification, all kind of stuff that you will need to build like a real life app. So that is something to like keep in mind that I'm going to show you like the basics, but we have a PR ready like for the alpha. We're going to put even more methods in our documentation, so you can do like even more things. So to get started, I'm going to show you, give you a tour of our GitHub repos, because like the first thing that we need to do to make an app on top of the Space Daemon is to download it and have it running on our machine. Because in effect, the Space Daemon, to use it, it runs as a background process. Like with our Space app, what we are doing is that it's an Electron app written in JavaScript. And when you start the app, at the same time, there's an instance of the Space Daemon that is fired up. And after that, we can start doing our actions like uploading files and looking at them and all that stuff. So here we are at github.com/FleekHQ. That's where we have all our repos for everything that is Fleek related. I'll zoom a little bit. And there are 3 repos that I want you to pay attention for this evening. The first one is Space Daemon. So that is where we actually are going to download the daemon. Now, to get the daemon, there are 2 ways to have it. The first one is to run it from source. If you want to run it from source, it's very simple. You go here, clone the GitHub repo. You clone the GitHub repo, and after that, there's another step. After cloning the repo, you also need to provide environmental variables. We use a lot of textile products, so like you need the secrets for the textile hub, stuff like that, and also some other environmental variables. I'm going to show you my terminal real quick, because I already cloned the repo right now to save some time. I'm going to make it bigger. So that's the GitHub repo. Oops. So after I have all my environmental variable, what I do is make in the root folder of the repo /bin/space. What is that going to do is the make is going to create the executable, and /bin/space is going to start the executable. But I'm not going to do enter, because if I do that, it's going to show up the secrets. So I already built the executable for us. So all I'm going to do is run the executable. I'm going to do enter. And now there's some logs that are going to appear as the daemon gets started up. And once in the logs, we see daemon ready. That is when we can start interacting with the daemon. So wait a little bit. No. Is it starting? Yeah, so it's a live demo, by the way. So we're gonna go, so if something goes wrong, that's why. But here we like take high risk with our demos. We do them live. So it's daemon ready. So now the daemon has started. So everything is awesome. Now that the daemon is started, we can start interacting with it. But that's the first way to start the daemon. Also a second method, which is the one I recommend a little bit more. I'm gonna move my terminal. It's running from an executable. So pretty much, instead of downloading the source code and generating the executable and starting it, you can just download the executable and start it directly, which is easier because if you do that, you do not have to provide the environmental variable. which means that it's a bit easier for you to get started. So it's the recommended manner to do it. So to download the executable as an alternative to running it from source, we're going to be from the Space Daemon repo, click on releases. And here we can just take the latest release and download the executable that corresponds to our machine. So this app, like Harrison explained previously, it runs on desktop. So it means Windows, Mac, and Linux. If you want to run it on something else like Android or like directly on the web, that is stuff that we have, we're gonna work, but not right now. For right now, the Space Daemon is for desktop. So if you are on Windows, you can either get it 32 bits or 64 bits. On Linux, same thing, 32 bits or 64 bits. And if you're on Mac, you take Space Darwin. It's the one that corresponds to Mac. And then you just execute it. It's very, very easy. And then on the terminal, once you execute it, you're going to see the same thing that I'm seeing right now, the logs. So it's the exact same thing. But now that we have the daemon, like how do we actually talk to the daemon? Like we want to tell the daemon, like upload this file, list all the files that I have and stuff like that. To do that, we have a space client. That's because the Space Daemon, we talk to it through gRPC. And we have our space client that allows you to do your Space Daemon integrations using JavaScript. So you can use it for your web apps, or for like our space app, we do it with Electron. You can also do that. So to download the space client, it's very easy. You go to the Fleek HQ GitHub on space client. And then you can do run yarn add Fleek HQ / space client. We have a npm repository for that, like this here. And then you are then ready to interact with the space client. I'm going to show you the example in a space workshop that we have. It's our third report I want to show you. So if I go back a little bit, there's this report, the space client workshop. This is just a workshop that we made so that we use like to show people how the daemon works, and it's something that we use during our live sessions, our demos. And in this case, I'm gonna run you through our workshop, which is gonna show you like how to generate a key, create buckets, upload files, open the files, and share the files. So it's gonna be a good introduction, like to show you like the basic functionality of the daemon. So this workshop is a React application that you can run, and it communicates with the daemon. So what you can do is this, git clone this repo. Luckily, I already did that. So here I'm going to open a new terminal, while always keeping the daemon running in the backend, because we need to keep it running as a process. So I'm going to go back here, space client workshop. I'm going to make it bigger. And I'm going to open it with my favorite editor. And then I'm going to do a yarn and yarn start. Now, while it is starting up, what I want to show you is where we are initializing our client. So here, this piece of code here, you might have seen it in the documentation I showed you like 5 minutes earlier. That's how you initialize the client. So you import the package, the space client package. You as an option, you pass the port that the Space Daemon is running on. In this case, is 9998. And then from then, this instance of the client has access to all the methods to communicate with the client. I'm going to open now this. Now it's done starting. That is our workshop. There's steps. It goes from 0 to 7. That shows some basic function of the workshop, of the daemon. I'm going to do F12, just show you the console, because this workshop inputs information on a console, and I want to show it to you. So at the first step, we're going to do generate key pair. The reason for that is, as Harrison explained earlier, the Space project is all about privacy. So like with the Space app, how it works is that you will, the user is going to upload files that are encrypted to IPFS. And this encryption is going to be done by a cryptographic key pair. So the user, it's a bit like Bitcoin, Ethereum, or anything else like that. The user is going to be identified with a public key, and it's going to have a private key that it will keep secret. And that is how he is kept private. So before you use the Space Daemon, you need to generate your key, because that is like your who you are as an individual within the daemon. So if I do generate key pair, here it says generating the key pair, key generated. So now the user has a new key, a new public and private key that, and you can now start uploading files that are encrypted. So, and also when you do this method, the generate key pair, it also tells the daemon, like, okay, now from now on, when you create new buckets or upload files or do things like that, I want to do it with the key pair that is just been created. So from now on, we will not like have to input a key or anything like that. It's going to be all managed by the daemon. So it's kind of simple for that. If I look just really fast in the code, like each step is as its own folder. So here, generate key pair. If I go to the index, we are importing the client, which is just this instead of the client that we initialized earlier. And from there, we call a method here. And there's an async, it's asynchronous. And it is generate key pair with force. That generate the key pair. And now we can actually start using the daemon. So the first step is we're going to create a bucket. So you might wonder, what is a bucket? So if you are familiar with Amazon S3, the bucket is where you put all your files in. So in this case, we need to create a bucket before we put files into it. So I'm going to create a bucket. I'm going to call it bucket. I'm going to do create bucket. Now it says creating buckets. And when you're going to be over, it's going to show you some more stuff. Here it is. The name is called bucket. And as you can see here on the key and here, you see IPFS hashes. That is because, of course, everything is also pushed to IPFS. That's why there's hashes like that. And this information, I want to show you in the code where to get it. So I'm going to show you here in the workshop, create bucket. So it's the same thing as before. So you import the client, then you call the create bucket method. You supply the method the right information, like in this case, the slug, which is the name of the bucket. And then it returns a response. And from the response, you need to call after function like get bucket. And it returns an object. And furthermore, this get bucket, if I go here, there's a helper method that calls get key, get name, get path, get created at, etc., which is the information that is here, the created at, the key, the name, the path. Now these methods, you don't have to memorize them. It's all documented in our documentation. So I'm going to show you like how you can interpret the response objects. Here, if I go to docs.fleek.co, you will see that our documentation is very complete. So we have here like our products. The first one is the hosting product. that Harrison talked about earlier, the storage product, and then the Space Daemon product, which is what is interests us. When I click on getting started, and from here we have a lot of information like how to install and stuff like that, but also we document every single method that is part of the daemon. Like here, create a client instance. We show you how to create the instance, how to create the bucket, how to list buckets, open files, to more auto function related to sharing, share a bucket, generate a public link, backups. So every method is documented in our docs, and it's very complete. And we take care that each time we add a new method, we also put it in the docs so that devs that are building on the daemon can easily have the information that they need. So I'm going to click on the create buckets. Here, this is the method that I showed you recently that in the workshop. And here we show you how to use the response object to get all the information that you need, like here the get key, the get name, the path, the created at, and etc. So if you need to get some particular piece of information with the methods, you can just look at the docs. It's going to tell you what you can access to, and each method is going to have their own methods to get information. So just something to keep in mind. You don't have to memorize anything. It's all very well documented. So I'm going to go back to the workshop, and I'm going to now create a folder. So inside our bucket, it's organized like a file system. So you have the bucket is like the root of the file system, and inside it you can put folder like slash my folder, slash my second folder. It's like in Linux, like you have your file system. It's very similar to that. So it makes it easier for you to organize stuff. So I'm going to create a folder inside my newly created bucket. I'm going to clear that. So I need to put the name of the bucket. I called it bucket, not very creative, but for the name. The path. So in the root, I'm going to create a folder called my folder. I'm going to click here. It says folder created. So the operation was successful. So, but now that we have indeed created a folder, how do we look into the bucket to did we really create a folder? So on the number 3, we got list directory. So that is pretty much, you give it a folder and it's going to look inside. And the root of the bucket is also a folder. So if I put here bucket and the root, what I'm expecting to see is the folder I just created. So I'm going to do that, click that. So it's fetching a directory, and it's going to return an array, and it has one element because I only created a folder. And indeed, it's called my folder. So everything is working correctly. So now that our folder is created, the next step is to upload a file to the bucket. So on my machine, before the presentation, I created an empty file. And what we're going to do is upload it to the Space Daemon. Now, on the background, what is going to happen is that this file is going to be encrypted, which means that and then pushed to IPFS, which means that only the user with his own key can read the file. So that's an important privacy aspect of the daemon. So if I want to upload a file, what do? Well, first step, I need to tell the daemon which bucket I'm going to use. So here, bucket. Then the path of the file on my machine. So on my case, like I told you, I created a file in my home. So I'm going to put the path of my file, this, and I call it my file. And then the path inside the bucket in which I want to put my file in. In this case, I created my folder, so we might as well put it in that. So here, my folder. So what I'm going to do, upload file, is going to put the file encrypted and put it in my folder. And we get some information. So it seems it was successful. I kind of want to show you like the code really quick. It's exactly the same thing as what we did previously. It's just calling the correct method that is also well documented. So here, upload files. There is something I want to show you about the upload files, however. It's here. So here it's client.add items. So the add items method is the one that we use in order to upload a file to a bucket. So it's just the same thing that we did. We put the name of the bucket, the target path, which is the path inside the bucket, and the source paths, which is the path on the machine. And as you can notice here, it's an array. So it means that if you have multiple items to upload, you don't have like to call this like 10 times. You can just pass in the array your 10 files, and it's just gonna get uploaded. And then it returns an upload stream, which is just a normal Node.js stream. You can look at the documentation of Node.js for that if you want to learn, but it's very simple. Like you do .on data, and then it gives you data, and then you can interpret that. We're calling it result, which you can just look at the documentation, like which method you need to call. So I'm going to go back to the workshop. Now we created a bucket, a folder. We put a file inside that folder. We can verify that the operation was successful by doing list directory again, but this time in my folder. So if I do it correctly, I should see my my file pretty much. So I do list directory. I get an array. Now there's two elements in my array. The first one is my file, as expected, because I just uploaded that. But then the second one is .keep. So that is just a file that we use internally we put inside the folder. So that's why it's there. So as you can see, the file is correctly uploaded. So everything is good. Now we can open that file, which remember is encrypted. So we need the daemon to unencrypt it. So to open the file, what you do, you put the name of the bucket as all before. Then you give the path inside the bucket of the file I want to decrypt. So it's the file is called my file, and it's in my folder. So I'm going to do /my folder /my file. I'm going to do open file. And now look at the result from the console. I know it's pretty small. I wonder if I can make it bigger. But I don't think so. Anyways, what is showing me is a path, and I'm going to copy paste in the terminal. So I'm going to copy this, and I'll show it in the terminal. So it's a path. So what is happening right now with this path is that the daemon went into the bucket, it retrieved the file, it decrypted it, and it put it in next to the executable. And this file is the file that I uploaded. So if I want to read it, I can do cat, enter. Cat is just reads the content of the file, and it says hello ! Which is what I put in the file originally. As we can verify here, I do /home /piraya /my file. Indeed, it's the same thing. So the file was correctly uploaded. And that is how you open a file. I'm going to close that. Next, I want to show you sharing a bucket. Now, the Space Daemon, pretty much, it's not just for uploading files, you can do a lot more with it. Like you can share your file or your bucket with another user. And like I told you earlier, the users are represented with their public key. So this still respect the user's privacy despite being shared. And this sharing, there's a lot of options that we have alongside it. Is that you can share to a specific person, to multiple person. You can share with everyone. So pretty much, if you do that, of course, it's not really private, but you can share the file with anyone. You can also have like access, like if you want to edit it or only view the file. So there's a lot of stuff that you can do like beyond just sharing. But if you want to share, I'm going to show you a basic function that we have. It's called shared bucket. And I do this. And you get a bunch of information. This information is the one that you need to then join the bucket. So like here, there's join bucket. So if I want to join the bucket, I copy this information over. So like I put the name, here the key, copy that. Then I copy the addresses. And then I would do like join bucket, and it would join the bucket. Now, of course, I cannot join my own bucket. It makes no sense. But if it was another user, he could then like join the bucket. But this share bucket and this join bucket is just one way to share. Like there are other ways to share. If you look at the documentation, like on sharing, we have a lot more functions that you can use, like generate a public link, stuff like that. We also have a notification system that is related to that, because like I told you, like we are developing a space app with that. And with the app, what we do is if a person shares with another person, we want a notification to appear. And so the Space Daemon is like all kind of stuff, like a notification system like that. And there are also more that is not yet in the documentation, because when it's going to be in alpha, there's going to be more stuff added, especially with the sharing. And that's it for the workshop. Now you might wonder, like, what is the last part? PowerGate. That is pretty much our Filecoin integration done through Textiles PowerGate. So just really quick about what is PowerGate. So Textile, the company, has a bunch of products that we use a lot in with the Daemon and pretty much with all our Fleek products, like buckets, threads, stuff like that. And the PowerGate is like a US product that is to interact with the Filecoin network, and it's like it bundles a Filecoin node, a Lotus node, and an IPFS node. And in our case, with our Filecoin integration, we do that with Textiles PowerGate. But this feature is not yet fully ready. We're more at the stage where we are working on it. So if you want to play with the part, this part, we have some instructions over here, completely at the bottom, at PowerGate, and to use it, you need to go to the Filecoin branch of the Space Daemon, download it, run it from source, which means that you need all those environment variables set up, and then you can use those commands to start up a PowerGate instance that you can then use to interact with the network. And in this case, I mean, I'm not going to run it in front of you. Just want to give you pointers, but here there's some code that uploads a file to Filecoin on a local net. And this code here is pretty much like the one that is in the PowerGate documentation that I slightly modified for our need. So it's just that. So like the Filecoin integration is definitely something that we are working on, and the whole idea with that is that we would love that, like, users with the Space app, they put files in the daemon, but it would be awesome like to make a backup on Filecoin. But like that is a big like use case of this. So make sure like to keep an eye open with that, because it's going to be coming.